Hello everyone, my name is Bruneau Babet. I am a member of the C++ R&D team. I work on the compiler, and before I used to work on frameworks. I've worked on object windows before, and back in the 80s I used to be a member of the technical support, back in the days when we had Turbo C and Turbo C++. What I'd like to talk about today is actually, it was a topic that was suggested by David. It was basically, how do you consume Pascal code from C++? I changed it a little bit. Initially, we were going to talk mostly about certain Pascal constructs and how would you do the same thing in C++. But I want to actually cover some of the areas that I work with the most recently. I mean, and are the extensions in the compiler that make it easier to consume object Pascal code, because the framework we ship, or the frameworks I should say, FMX and VCL, are both built in object Pascal. And what happens is C++ can access this code because code that comes from Delphi is fully accessible to C++. So I have a little something just to illustrate what happens. You have some pass files, we put it in a package. You don't have to put it in the package, but in this particular case, I'm putting in a package, and we compile it with a -JL, and then you get a bunch of HPPs, and then you get a library, and potentially a BPI and BPL if it's a package, or you might get a bunch of OBJs. And then to consume this code, you need the header, the HPPs that explain, that exposes the API, and then your C++ code, of course. And the switches you would use, the TJ or TV or TF there says TVs, I'm linking with VCL, TF, I'm linking with FMX, and TJ is, I'm just using the Delphi RTL. By Delphi RTL, I mean like the actual RTL package. So if you're using things like NC string, Unicode string, variant, and TDate time, and even some of the helpers like IOUtils, you just say TJ. This is really because I'm using the compiler here as the linker also. I'm just going to let it link the whole thing, but you have the option of calling the linker also yourself. After you get the OBJs from your CPP files and the OBJs from the Delphi side, you can link the whole thing. I've added BCC as one of the linker because I think people often forget that the compiler is also a linker. If you just give it object files and libraries, and it will go ahead and do its thing. So this is how we access Delphi code from C++. That's the mechanics of it. As far as the compiler itself, there are a bunch of extensions that have been added to the compiler to make consuming Delphi code much easier. So I've broken the extensions here into 3 little groups. One group are the keywords that we've added to the language. The other group is the decal spec. So decal spec already exists, of course, for a lot of things that are Windows centric, like DL import, DL export, and UUID of an UUID. But here I've pointed out just the particular decal specs that have to do with Delphi, consuming Delphi. So you will see these decal specs show up in the HPPs that I mentioned in the previous slide. So when Delphi is the Delphi compiler is building the pass file, it generates a bunch of HPP files. Those HPPs will contain a lot of those decal specs: dynamic height base, Pascal implementation, Delphi record, Delphi class, Delphi return. I can go into the details of what each one does, but that would be outside the scope of this talk. So I'm just going to point them out. I will talk a little bit more about the keywords themselves, because the keywords are key to be able to access certain features of the Delphi language. And I will also touch on the areas of the Delphi language where we have, let's say, we have work to do. You know, like we have certain things we still have to do where you can't fully access a particular feature of the Delphi language, or you can't fully express, I should probably say, express it in C++. At this point, we can access everything Delphi exposes mostly 99%. But there are certain things that you can do in Delphi that you cannot express. You can't do the same thing in C++. So you can consume it, but you can't create something similar. So those are the areas. I'll cover those as we get there. So the first thing is a bunch of runtime. Okay, so besides the compiler, there's also a bunch of runtime support, a bunch of classes that we've written. These, they form the glue between Delphi and C++. And for the most part, they cover things that are built in the Delphi language. So an NC string or a wide string or a currency or a tdate time, all these are built-in types in the Delphi language. By that, I mean the compiler knows them intimately in the same way that the compiler knows about an integer or a bool or a boolean, I guess I should say, or a char or an NC char and so forth. So these are built-in types. So we need to be able to replicate those types in C++. So we wrote a bunch of runtime that for the most part matches the name in Delphi, but those runtime actually are not really your typical runtime. They're not written the way let's say STL is written, or the way the C++ library, or so, because they have a little bit of compiler magic behind them. So I won't go into compiler magic, but I'll just say that those runtimes, the classes like NC string, wide string, Unicode string, currency, tdate time, they also use some of the keywords that I mentioned earlier here. In particular, there's one here called Delphi return. That Delphi return keyword tells the compiler, you're going to pass this parameter, this type, and you're going to return it the way Delphi does, not the way C++ does. So if we go back here, like the class NC string or wide string or Unicode string, they look pretty much like any string classes. You know, they hold a character pointer, which is the data, and they have subscript operators. They have ways for you to find, to append, to delete, to search. But the way they are passed and the way they are returned is different from the way any other string class would be passed or returned. And that's the magic of that decal spec Delphi return that tells the compiler, hey, you have to do what Delphi does with the string, not what C++ would do. And that means, like, for example, the way C++ copies an object, the standard says exactly, you know, when I'm passing by value an object key and I'm giving it to someone else, you make a copy. That's just the way the standard works. Well, in the case of Delphi strings, that doesn't happen, actually. The string is not copied. The string is passed as is on the other side. And then there's a little bit of magic that happens in the prologue and a little bit of magic that happens in the epilogue that basically bumps the ref count of the string to make sure that it sticks around in case the original one goes away. Well, that wouldn't happen in the normal case unless you were, let's say, starting a new thread and passing a string somewhere else. And then the calling thread might go away. So, or the calling scope might go away. So the idea is, it's the same idea behind the scene. I mean, the reason C++ does a copy is exactly because I can't rely on the original. And Delphi does it slightly differently. You pass the string, and then there's an add ref, if you want, that happens in the prologue and a release. So each one of those types has their little quirks, each one of those types, but you don't see that. I mean, the compiler does the quirks behind the scene. The main thing is those types are there to support the built-in types of Delphi, like sets and interfaces. The one at the end that I've put at the end is meta class. Meta class is something that we don't even have in C++. It's root. It's key to Delphi classes. It's basically, if you want a type that describes a type, it's the metadata. So I will delve a little bit more into meta class in a minute, but I just want to list all the runtime that we have here. Meta classes. Okay. So first, I'm going to talk about the things that are not quite so powerful in C++ right now. All meta classes in C++ are type erased. By that, what I mean is they all collapse down to one type. The term type erasure is used very often for, let's say, the way templates are implemented. You know, you don't want multiple instantiation of the same template. You might have some base template that collapses everything to a void star, let's say. And then that way you don't get bloated code. And here what happens is all the meta classes of Delphi are type erased or collapsed down to the meta class of TObject. So basically, we collapse all the meta class as far as the definition of the class, the declaration of the class, to the meta class of TObject. So when you declare a new meta class in Delphi, C++ sees only that it's a meta class of TObject. So we won't see any particular class methods that meta class has, and we won't be able to invoke those class methods as a result. So, so that's one of the areas that we're working on, is how do we expose the whole meta class concept in C++. It can be done with runtime. That's easy because you have a shadow hierarchy on the side that will just shadow the real the class hierarchy, but that doesn't scale very well, and that requires too much typing. And so we need to have this done automatically by the compiler. And so there are some ideas, and probably would involve at least one new keyword. So some of the things that you can't do with meta classes, you can't invoke the class methods. That's the first thing. That's a result of the type erasure. You can't specify a meta class when you're creating a new class. So if you say new tfoo, behind the scene, the compiler calls class create, passing it the meta class of tfoo. That's really what happens behind the scene. But in Delphi, you can actually use a derived meta class to create the tfoo, not in C++. So new tfoo will always get you a tfoo. It won't get you a tfoo derived. Now, that's not such a problem in VCL because VCL doesn't do the factory pattern with meta classes, but FMX does. So very often what we do, we have little helpers in the FMX library that are there just for C++. But the things that you can do, you can access a types meta class. That's the class ID keyword. And you can also define class methods in your class, and those automatically become methods of the meta class. So if you declare a new class, let's say tfoo bar, and it derives from TObject or in any other class of the FMX or VCL or RTL hierarchy, and you declare new methods in it, and you tag those methods as class methods, they are really methods of the meta class of this class. So those two things C++ can do. You can add methods, and you can access, but you can't specify the meta class when you're creating one, and you cannot invoke class methods off a meta class. You can invoke class methods off an instance. So you can't invoke the class method off the meta class data, but you can do it on an instance of the object. And most of the time, you have an instance when you're talking to the meta class, except when you're trying to create a class, you don't have an instance yet. So that's why the second item, which says you cannot specify a meta class when creating a class, well, that's the problem. You don't have a class yet, so you want to create a class so that you can access the meta class methods, but you can't specify the meta class. So we're working on those two things, and we'll get them resolved in some upcoming version. The big question is, so what is a meta class? Well, the meta class is actually just the VMT, the virtual method table. We're all very familiar with that. You have virtual functions, and we know that behind the scene, the compiler generates a little table. In the C++ way of thinking of it, the table just has pointers to the functions. So, I mean, if you look at, let's say, COM interfaces, the way they are done in C, not in C++, actually you see the raw Vtable, and you see a function pointer, a bunch of members that represent function pointers that are the pointers to the members of the interface. So, but the Delphi VMT is actually a little more complex. I mean, I made a little diagram here to show it. At offset 0, which is what you get back when you're asking for the class ID of a type. So at the bottom here, I've shown, if you say class ID of a type, which gets you the meta class, actually it gets you the pointer to the first virtual in the class. So that's fine. That's great. That's the way C++ also works. You know, if you have an object and it has a Vtable, and the Vtable, you know where the pointer in the Vtable is, you go there, you're going to see in the Vtable the address of the first virtual, and then the address of the second virtual, and so forth and so forth. But what's interesting with Delphi classes is there's a bunch of goodies at the negative offsets of the Vtable. And the Vtable is not just made up of virtual functions. It has pointers to all kinds of data structures. So that's the meta portion, because the data structures describe the type. They describe like how many published methods it has, how many dynamic methods it has, how many published fields it has. It also has like, just, oh, if the class implements interfaces, there's an interface table. So all these are at negative offsets of the VMT or the meta class. So I'm going to use the word VMT and meta class interchangeably because they're the same thing. Well, the meta class is a VMT plus more, if I may use that term. So what you're getting when you say class ID, you get a pointer to the first virtual. So that's why I made the arrow go there. But really, the whole data structure is a little more complicated. And there's one peculiar thing that's very interesting. At the very, very top, at offset negative 88, there's a pointer that comes back to offset 0. So it's interesting. The top of the table has a pointer to the middle of the table, which is where most people are interested, which is the VMT itself. So in case you're wondering, why do we have this pointer at the top to go down here? It all has to do with modules and DLLs. So when classes are exported and imported across, we need an extra indirection so that we know when we're doing the fix-ups, we know that, oh, this code is importing a module, a VMT from another module. So the pointer at the top allows us to do the little game that you need to do with the way data is exported and imported in DLLs. I mean, I don't need to go through the details, but basically what happens is there's a little function. Basically, when you're exporting data, you're actually exporting something that then points to the actual data. Back in the early days, I believe, if you were to export data from a DLL, the Microsoft toolchain actually had you, when you were importing the data, you actually had to show, let's say you were exporting an int. When you were importing, you had to actually show that you were really importing an int star, an int pointer, and then that would force you to do the indirection to get to the int, because that's really the way things work behind the scenes. So here there's the same kind of mechanics working there. There's a pointer at the top. So that's one little thing. So the other thing that's interesting is the meta class and the type info go hand in hand. So type info is, Delphi has its own type info, which is distinguished, which is very separate from the C++ type info. So the two structures have pointers back pointers to each other. So the VMT has a pointer to the type info, and the type info, if it's a type info of a class, has a pointer to the VMT. But it's actually interesting to see which pointer it points to. So I've kind of drawn the arrows so that you can see. I've also shown the mangling, although that's not really interesting. The @ $XP and then $for type. For type is just the for the length prefix, and then type is the type name. So if this was t-object, it would say 7 t-object. And so that's just, if you were dumping OBJs, you would see that. And the same thing with the actual VMT itself is just @ type @. So the type info and the VMT, that's not. And also the offsets that are in there, the 88, 84, and 80, and so forth, those of course apply to 32-bit. If you were in 64-bit, you actually not quite double. I would say you would double those, but not quite, because we actually have a few slots reserved at the negative offsets in the VMT of our Win64 compiler, because it's Itanium, and Itanium already reserves three slots in the negative offset of the Vtable. So it would be doubling all the offsets here and adding the size of 3 pointers. So basically, everything negative would be pushed back further by 24. So okay, so enough of the slides. I want to actually show something useful about it. So first, I'm going to go back and here and say, there's something very useful about this VMT. When I'm debugging, very often I get to a point where I'm in the CPU window and I don't really know where I am. I see that the compiler is about to, let's say, take a particular address and dereference it and then make a call from offset, I don't know, offset 4, 8, 12, 0. And right away I can, intuitively, I'm like, oh, okay, we're calling a virtual function, probably, yeah, that's a Vtable. But at that point, I want to know the Vtable of what type, what class, where am I right now? And if you look at offset 56, there's a little pointer, -56, that points to the class name. And so that's actually very useful. And I've done this so many times, so I've decided to put it here. I'll show you. It's kind of a little, well, it's not something that comes easy, but you can find the class name of a instance by doing this little nasty cast here. So I'm actually going at offset 56, just 14 times, and then casting it to, first I start with the instance. So I have a T object, let's say. And then I say, well, first we're going to get the Vtable. So I'm going to cast it to an unsigned star and then dereference that. That gets me the Vtable. And now I'm going to say, oh, I need to do a little bit of negative arithmetic with that Vtable. So I'm going to, I want to do the arithmetic by unsigned. So I'm going to go negative. And then at the end, I'm going to cast the whole thing to char star just to look at the name. I've shown a little example here, but I actually will switch to here and bring up a project and do a little bit of code. So to show, no, that's the project itself. So this is just going to be a little sample where. So I have just a little button click here, and I have a little function that just returns a random object. I mean, I just know that the object is T object. I don't really know what it is, really, which T object. I've made the code. This is all very synthetic. This is just all manufactured code just to show. I've written either a string list or a T list or T bits or T object itself. And when I'm here in the show message, I'm going to do, here's I'm doing this little nasty cast. Now, that's not very useful, but no one writes code like this, but I'm just going to run it so that you can see what happens. I'm going to click it, and here's so now I got T list of system integer, okay? And I'm going to click it again. It's just going to be random, so, okay, T bits. Now, if you look at the data that's been printed, it looks like there's some garbage characters in it. And indeed there are. Like there's this funny ASCII character showing up before, and then there's another funny ASCII character showing up afterwards. Same thing here. You see the little, ASCII character, and I want to maybe hit T object. I guess my random routine is not quite random. Well, it's not mine. It's, oh, here's T object. So yeah, there's this little funny ASCII character in front of it. I mean, earlier I mentioned if it was T object, it'd be 7 T object. Well, this happens to be the ASCII character for 7. So the string is actually length prefixed, and the string is not null terminated, which is why we're going beyond T object. So really, if I really wanted to print this, I would cast it to a short string first, and then have the short string converted to an NC string. And then that way, the short string conversion knows, oh, it's length prefix, and then when you go to an NC string, we do the right thing. But this is just for demonstrating purposes. Typically, it's not like this that you're going to see that. Typically, what's going to happen is I'm going to make this, I'm going to just create a fake condition here where I'm going to load the pointer that I have into a particular register, and show you more or less what typically happens when I'm dealing with this kind of issue. So okay, so now I've just loaded the object in EAX. Okay, so, and I'm going to go to the CPU view, and here's my little move to EAX here. So usually it's not like that, but usually it'll be something else. It'll be like when I'm looking at code and I see here's a good example. You can see here the compiler is loading EAX. I mean, basically dereferencing EAX, putting in ECX, and then making a call at ECX -4. Ooh, good. As soon as I see that, I'm like, hey, we're dealing with a Vtable here, and we're calling offset -4. I happen to know that offset -4 is the free instance. I mean, that's basically the destructor. So the delete object is doing that, but that's the kind of scenario that I'm going to be in. And so at that point, what I'm going to do, if I'm in the debugger and I want to, so I've crashed somewhere and I can see that I'm going to add a watch, and I just copied and paste. So, and I'm going to switch to EAX. Boom. And now I can see in the watch window right here, the funny character, t-object, at thing. And so, and you can do the same thing with the size. You can do the same thing also. I mean, there are lots of other things. You can follow the tables in the CPU view. Now, I don't expect, this is not something you would do on a daily basis, of course, but when things crash or when you're in the CPU view and you really don't know where you are and you want to know, like, which class am I dealing with, or, you know, what's the size, or even, is this really a vtable? Because sometimes we crash and I look at this, I'm like, no, that doesn't look like a vtable. And what I would do is I would just go to the vtable and look at the pointer. You can see there's a bunch of virtuals here. The free instance, the new instance, the default handler, dispatch, before, after. All these functions happen to be in the system unit. So they all are at the same addresses, more or less. I mean, they're just a few bytes away from each other. And they all look like valid code. And then all of a sudden, you have the pointer to the parent class ID, which might be different from that. And then you have a size. The size is usually fairly small. How big is a typical Delphi style class? I don't know, 300 bytes, 400, 5. I mean, so you will see a bunch of zeros with 300s and 400s. So by just scanning the memory, I can tell, yeah, this looks like a vtable. Or I'm like, no. We ended up in a totally different, when bad line, something bad happened before. And of course, the name is always the easy one to follow, to kind of catch the name. So anyway, so this was the vtable thing that you can do. This information is useful, and for people who work on the compiler, probably it's more useful, but it can become handy also for other people. So this was a screenshot of what I just showed you. So the next thing I want to talk about is Delphi exceptions, because that's an area where there's an added benefit to actually using Delphi exceptions, not just for the fact that, well, Delphi uses exceptions, you need to catch them, but Delphi exceptions, the exception system in Delphi handles both asynchronous or structured and synchronous exceptions. So in C++ or C, if you wanted to catch, let's say, a divide by 0, you would have to do try except, or what we call SEH, structured exception handling. And that's fine. I mean, Microsoft has a wonderful extensions that we support to do that. But now you have two separate handlers. You basically have your structured exception handler, and then you have your language exception handler. So for the bad things that could happen for divide by 0, an access violation, some overflow or whatever, you have all these structured exception handlers. And then for your language exception, you have your try catch. Well, when you're linking with the Delphi RTL, it actually traps structured exceptions and turns them into language exceptions. So here I'm doing a little demonstration, a little show, but I'd rather actually show the code, so I'll get out of here. Oops, that's not what I meant to do. I will relaunch this afterwards. You'll show me how to do that. Should I just
go from current slide?
Go from
current slide. No, second from the left.
Oh, perfect. Thank you. Now I want to switch to the machine and I'm gonna open a new project and just close this one. Yes, we can save the change. So so here, the thing that I hide in the slide, I have a little compute program. It's totally synthetic. And I'm passing it ij, and I have a little ternary operator that, does the wrong thing. If I is non-zero, it multiplies. But if it's not, it actually divides, which means when I is 0, I'm going to do a divide by 0 here, which is not a very good idea. But my goal here is to show you that the exception mechanism, the language exception mechanism, will catch it. It's not going to go, the wrong way, where the OS will catch the exception and tell you this program misbehaved. So I am just going to do that. Now the debugger catches the exception. The debugger gets first crack when you're running on the debugger anyway. But I'm going to say continue. And here's my little exception message. So it got caught from Delphi as a Delphi exception, as an exception message. That is something that's very advantageous. I mean, it depends. If you want to do SEH, that's perfect. If you're linking with the Delphi runtime, you get that for free. If you're not linking with the Delphi runtime, you don't get that. So when does it matter? When you're doing console applications, you may or may not link with the Delphi runtime. It's up to you. So a console application that links with the Delphi runtime would benefit from this handling of async exceptions, and a console application that does not would not, and that's perfectly fine. You probably would put some SCH try except handler around if or maybe the app is not supposed to crash, and therefore the console app just doesn't handle that kind of issue at all. The other thing that I wanted to point out with exceptions is with Delphi exceptions is that I'm going to move to the next one. It has a very, very complex hierarchy. I mean, as with any framework, if you want to use objects from a framework, one of the root things to know is, what's the object hierarchy? What do I have available? Like, for example, if you're using GUI, you want to know, oh, I have a T button, I have a T edit, I have a T memo, I have a, and you usually know, oh, they derive from, let's say, T win control, and those, derive from whatever, T control, and so forth. So that way you get to know the hierarchy. Here, I am just showing the exception hierarchy, a very, very limited set of the exception hierarchy from Delphi, and I'm using the C++ Class Explorer. And part of consuming Delphi code is actually getting to know the Delphi code. And so I'm going to do a little plug here for the Class Explorer, because it's actually extremely useful to do that kind of thing. So I'm just going to launch the Class Explorer. It's going to browse this little code that this little sample that I just showed you. And I'm going to sort by namespace here. I'm going to go to the sysutil namespace. And you see all these things that starts with E. I'm going to grab all of them. They're all the exceptions. And then I'm going to just say graph. Okay, well, this graph is a little too big, so I'm going to change the orientation from left to right. And I'm going to scroll down a little bit. And here you get to see exactly how I got that screenshot. Here are the exceptions. So, but it's actually this particular feature of the Class Explorer is very useful, and I use it a lot, and I use it even with other people, because every once in a while I get somebody who comes and says, how do I, oh, where is this method that does this? Oh, which class has this particular thing? Can I use this feature from this class? And a lot of these questions can actually be answered if you know the hierarchy. And in the old days, we used to have those big posters that we shipped. Well, back in the days when we had those big boxes and all those disks in them. So we had these big posters of the framework, even for object windows and VCL and so forth. Now I basically generate my own little poster. You can, with this thing, you can actually save as SVG and get a nice little, and you can also customize the poster for the classes that you want to use. So you could actually say, I want it with this and this guy, and I want it with this guy. And as you add things there, the graph is adding the hierarchy. So anyway, I'm not going to talk too much about the Class Explorer, but I just wanted to show that, to get to know the exception hierarchy of Delphi, and one way is use the Class Explorer, and it's a quick way to navigate. I can learn more about the exception hierarchy with the Class Explorer than I could, looking online, even with our online docs. So I mean, our online docs are great, but I just want to mention that. How would you use a Delphi exception yourself? All Delphi classes are heap-based, meaning you have to new them. You cannot just put them on the stack. You'll get actually a compiler error. But we made an exception with exceptions, because in C++, the mantra is throw by value, catch by reference. Throw by value, catch by reference. That's the mantra. I mean, it's got nothing to do with Delphi here. I'm talking about just generic exceptions, generic C++. So we wanted to have the same syntax in C++. So when you're throwing a Delphi exception, you actually say throw exception. You don't say new in this case. Behind the scene, we actually go ahead and say, fine, no problem, we'll new it. So the compiler actually generates this off the heap, by the way. So it's a little example here where this is my little function that will throw if the condition is true. And then at the bottom, this is the case where this is just the case that exercises it. Let me just go back to the slides and show. I keep doing the wrong thing here. From current slide. So, no, that's into the code itself. So here's the code, the same code that's we'll throw. So I just want to show here, I'm just throwing exception. This looks like a value object. This doesn't look like something you've newed, but behind the scene, actually, the compiler will do the right thing. So, and then catching by reference. So throw by value, catch by reference. I'm just going to, here we go. Thrown from C++. And the catch clause here is this. I just executed. So where's the program? Here we go. So it just broke there, and I'm just let it run. Here's the message. So same idea, because I've seen a lot of confusion where people say, oh, Delphi classes are heap-based, so I should new it, and then throw a error, and then things don't make things too complicated. I added something at the bottom here. I said, beware, async exceptions are not always recoverable. That's actually what the OS documentation from Microsoft says. So meaning, if you did a divide by 0, okay, maybe you'll recover. But if you did an AV, if you had an access violation, you don't really know what state your program is in. What did you just write over or try to write over? I mean, how far did you get by or something like that? So the idea is, yes, Delphi will turn your async exceptions into language exceptions, and it looks like you can just catch them, do whatever you want to do, and keep going. But, okay, take that with a grain of salt. Do the right thing. You know, if you have things data that needs to be saved, save them. Inform the user. Maybe tell them to exit and restart or something like that. I mean, I'm not going to go one way or another here. I'm not going to say don't do it or do it. I know plenty of code that actually uses this feature, but the warnings from the OS is there, and it makes sense. I mean, if you think about it, if you've just had some memory that's been written over, and then you probably should do the right thing there. So, okay, now I'm going to switch into a different gear, which is you have some object Pascal code and then you want to write the same thing in C++. And that's something that happens a lot because our framework is written in Pascal, so you often will look at the code and see it. And also because if you search on certain new features that we've created, maybe online, you'll see a blog, and the blog might be in Object Pascal. Often we also have blogs in C++. I know David and others do a very good job at highlighting or writing the same thing in C++. But the biggest nightmare, I think, when somebody looks at Pascal code and wants to go to C++ is dot. In Delphi, all name lookups are off a dot. Doesn't matter whether you're talking about a pointer, a static class, a class method, it's always a dot, a field, a function, and it gets even more complicated. When the function doesn't take any arguments, you just say a.b or a.func. You don't even need to say open paren, close paren. So when you're looking at Delphi code and it says a.b.c.d, guess what that could turn into? Oh my God. The combination would be mind-boggling at this point. Because each one of those dots could remain a dot, become an arrow, or become a colon or scope resolution operator, whatever you want to call it. So, because it totally depends. If we're talking about a record and you're accessing a field, it's a dot, it stays a dot. If we're talking about a class and you're accessing a field or a method, it becomes an arrow because the class is a pointer in C++. If it's a static method, it'll be colon. If it's a class method and you're using the type name, it'll be colon. Now you add to that the fact that you could have open paren, close paren. So I gave a little example. A.b could become A.b, or A open paren, close paren dot b, or A.b open paren, close paren, or A open paren, close paren dot b open paren, close paren. Now repeat the same thing above with the arrow and with the colon colon. Now imagine what would happen if it's A.B.C.D. So this is the key, and it's the dot crisis. I usually think of it that way. I don't think I use that term, but it's the idea of everything is a dot, and now I have so many other possibilities. So it's if you look at the declaration, what the Delphi type got turned into, then it's pretty straightforward. Was it a record? Was it a class? Was it an interface? Is it a static method, and so forth? And also, each name, is it a function? If it's a function, then you have to be very, very wary about like the missing open paren close paren. So I gave a few examples here, like, so TUI application, OC class shared applications turns into really the first dot becomes a colon colon, the second dot becomes an arrow, and there's an open paren close paren at the end. And then another example, tvalue.empty.toString. Well, the first dot becomes a colon colon, the second dot remains a dot, but the last one becomes open paren close paren. Now, if you replace toString with isEmpty, which is a property of tvalue, then there wouldn't be the open paren close paren at the end. They actually, in the case of isEmpty, they would both be identical. There'd be tvalue.empty.isEmpty, and the C++, no, the C++ side would be tvalue colon colon empty dot isEmpty. So the dot would remain the same. So enough of the dots. So there are a few other constructs that I've noticed that can cause problems because they are extensions of the language that we've introduced. So it's not very obvious what you should do there. One of them is when you use system.typeinfo or just plain typeinfo in Object Pascal, what you should do is the extension that I mentioned earlier, Delphi or TTI. When you're calling a Delphi API that expects a GUID, but you see code that passes to it an interface, that's where the compiler automatically infers the GUID from the interface. What you need to do in C++, you need to use UUID of. So that's here. When you call a function in Delphi that expects a meta class, as in create form, you pass it to form1. On the C++ side, you need to pass class ID of the type. That gets you the meta class. This sign is probably very common. Everybody knows it. Every VCL app and every FMX app does the same thing. The problem is you run into some other API that expects the meta class. It's easy to forget that you're doing meta classes all the time with class ID, and you're like, oh my God, you pass the type name, and then the compiler tells you incorrect usage of the type name and so forth. So anyway, so class ID is your friend. Casting. Delphi has is and as. Okay. And so if you say if something is something else, if obj is tsum type, the best way is to actually just use dynamic cast in C++. You dynamic cast the source to the type that you want to go. In this case, since tsum type is a class, it becomes a pointer on the C++ side. Then this does the trick. And usually the way you would write it is actually if open paren some variable name equals dynamic cast, meaning in the if statement, you can declare a variable and evaluate the if all at the same time. And if it works, you enter the block, and now you have a new variable pointing to it. Because the Delphi case where it says if obj is some time, the next thing is probably going to do a cast to get the sum type out of obj. So there's a little shortcut that you can do there. As is another operator in Delphi. I didn't put it here. Well, I put it in the case of interfaces, but I want to talk about as in the case of classes. As does something that doesn't quite exist in C++, because as will actually throw an exception if it fails. We'll throw an invalid cast, I believe. So if you really, really wanted to throw an exception, then you would do a dynamic cast, and if the dynamic cast failed, you would raise the exception. But typically, you can just do dynamic cast even for the case of as, and just check the return value if it's nil or not. We don't have a cast version that will throw an exception. So on the Delphi class, so you just use dynamic cast, and that's the way, and then just look at the return value. Interfaces to object is a little tricky. Oops, that's not what I meant to do. I clicked on. In Delphi, you can use as to go from an object to an interface or from an interface to an object. In C++, there's no such thing as the as. So there are two things you can do. To go from an object to an interface, use the getInterface method. Just create the variable of the type of the interface you want and just call getInterface. It will return a Boolean if it succeeded. And if it succeeded, it fills in the interface for you at the same time. And to go the other way, you have an object, and now you want to get, no, you have an interface, you want to get back the object behind it. For that, we have a little runtime. We have something called interface cast. I didn't make it bold there because it's not a keyword. I don't want it to look like static cast or dynamic cast or reinterpret cast or const cast. Interface cast will do the little magic behind the scene if you actually want to step through it. It's just a little template magic that behind the scene does the right thing to get you back the object from that implements an interface. Of course, it might fail if that interface is not implemented by a Delphi style class. An interface could be implemented by just a regular C++ class, then that would fail. But anyway, so those are the casting ones. I have a few more here. They kind of cover a few other areas. One area that's very dear to my heart is using Rye. I mean, I see a lot of code using try finally, and sometimes you can rewrite it with underbar try and underbar finally, but it's much better and preferable to use auto pointer, or if you are with C++11, use unique pointer, and and you don't have to worry about a lot of things. It makes something that's like 6 lines of code on the left become 3 lines of code on the right, and just call auto pointer, construct your class, do whatever you want to do with it, and let go. So at the end of the scope, it will be deleted, and if an exception is thrown, it will be cleaned up properly and all this thing. Sets is also another area where I see a little bit of struggle, and that makes sense because of the way we use the operators. The set class was written in the 90s, and I think back then IOStream had just come out, and we were really, really eager to replicate what IOStream does. If we were to do it again nowadays, we probably would not use those insertion operators, but what's done is done. So here's a case where you call string replace with a set, and here's how you do the same thing. I threw the other cast here. This is a cast where sender is a button. So the Delphi code is not checking if sender is a button. Okay, it knows. So the way to do it in C++ is just use a static cast. So anyway, that covers the code conversion. I want to talk about another feature of the Delphi language that's been around actually, I think, since Delphi 2009. Anonymous methods were added back then, probably around the same time we added generics. But it wasn't pervasive throughout the framework, but now it's become very pervasive. FMX uses it, the RTL uses it. And so what is it? It's a local function. It's an unnamed local function that you can pass as a parameter, as a return value. So the way it's declared, I'm using the examples from T directory here, here's a filter predicate. It says reference to, that's the key there. The reference to means you're declaring an anonymous method. And the anonymous method is this function that will take a string and a tsearch and return a Boolean. And how do you use it? Well, here's an API that expects one such thing. Get files, you give it a path, and then it wants one of those predicates. I'll explain how it works. So the way it works is you call get files, and you give it the directory where you want to get files. You want to search. It's basically what it's doing behind the scene is find first, find next, if you remember the old APIs. But it wants to give you also the flexibility of selecting which files you really want to find. So, and the way you do that, you give it a little anonymous method. And that's the example here. You just pass it a little function right inside as you're calling get files. You have a little function. And that function will do a little test. In this case, this function will check that the extension matches a particular extension in here, pass files. So the beauty of this is locality. I mean, the function you're writing is right there. You don't have to write a separate callback like the way we used to use function pointers before. And or a class and some members or something like that. It's all local. It's very easy. You can read. You can see what you're doing. So um, how is this exposed in C++? Or maybe, well, I was going to show how it works in Delphi, but once we switch to the IDE, then I'll do both. I'll do the C++ and the Delphi at the same time. Let's just talk about how are anonymous methods exposed in C++. Well, we kind of show you the underbelly. We show you what the Delphi compiler is really doing. Behind the scene, when you create an anonymous method, the Delphi compiler is actually creating a class. And in that class, there's a method, a member called invoke. And that class implements a particular interface. And the interface, that interface is actually the anonymous method. It's the interface that manages the lifetime of that class that was created. And so behind the scene, it's basically creating the class, putting all your code inside of a member called invoke, and then passing it to the receiver, to the parameter, the API that expects the anonymous method. And then that API uses the interface to call invoke. And then when it's done, because of the way interfaces work, the ref count goes back down to 0, the class is deleted. Now, why is there a class? There's a class so that it can capture. Meaning inside of that little local method, you can make reference to variables that are outside, like in the immediate scope or maybe even in the outer scope. And the class that will be created will actually capture those so that you can, the values of those variables can be used while you are in the local routines. So that's the whole idea of the class. Now, for anybody who's familiar with recent C++ standards, or even just, I mean, lambdas have been around for a long time, would recognize that what I describe is very similar to a lambda, except in a lambda, there isn't an interface and a class. It's just a class. So I will get back to the lambda side. I want to show how we used to implement anonymous method before C++ 11, before we had C++ 11. So we would actually do exactly what I just described. You would create a class. It would implement the particular interface. You would write an invoke method. And that class would, its constructor would capture anything that you want to refer to inside of your invoke method. So on slide, that's not also easy to see. So I'm going to go back to code and bring all that up. So let's see, where is it? Anonymous method, here we go. So I have two versions of this first. So I am going to scroll this code back a little bit. So there's an if 0 at the top here. Oh, I'll collapse it. We'll use the IDE. So this is the old version of the code. Okay, so I'm going to call getFiles here, and I want to pass it the predicate. But to pass it a predicate, I had to write a class called myFilterPredicate, and the class had to capture whatever I wanted to pass. And then I had to create the predicate here, pass it to getFiles. And then getFiles does the magic and it calls my method. And so I'm going to run this version of the code. Okay, so here you can see that I called getFiles. I'm just going to show it a little more. GetFiles. And getFiles, of course, has a little helper do getFiles that called walk through directories, that called do getFiles. And then here we end up in my code. We're calling a little thunk. That's because it's a virtual method. And then now we're in my code. Here's the invoke. So that's how the whole thing worked. I give it an actual class. Well, I give it the interface, and it basically invokes the invoke method. And so I am going to set a little breakpoint here. And why is this breakpoint not? Oops, having a little trouble with that breakpoint here. It's not. So now my invoke is being called multiple times. I really want to set a breakpoint at the end of the program. For some reason, that's not working. I'm going to bring the thing, hopefully the breakpoints. I'm going to take this out. Not liking this at all. Okay, I'm going to switch to Win32 just to see whether I have a little better luck here. Because I'm using Delphi, as I mentioned earlier, I guess you'll get to see what I haven't done. I need to link with the Delphi runtime. Okay, so even though this is a console app, I need to link with the Delphi runtime. So this is good. This happened. Okay, so in Win32, I'm just going to set a breakpoint here. Okay, so now I'll step over that and we'll look at it. So we found 0 files with CPP. I know why. It's because one more time, because I switched to the platform that I wasn't expecting to run. As you know, we create our EXEs not in the source directory, but 2 levels down. We create them in the platform and then the config. So of course, since I'm using get current directory, which is where the EXE is running, it didn't find any CPP files because there are no CPP files in that particular location. So I am going to switch the working directory to see documents. So Embarcadero, Studio, Projects, CodeRage 9. Okay, so we will run from that directory this time. So I'll run this one more time and step over that. And yes, we found 7 files. So, and I mean, I could step, let's just run to here, and you can see the 7 files are pretty much the files that I've shown you earlier, like the meta class we were looking at, and then the Delphi exceptions, and this is the CPP anon. So I just found a bunch of CPP files. So this is the old way of doing it. By old way, I mean like creating a class and doing the hard work. So now I'm going to show you a method of doing it with lambdas. I'm going to switch the if to 1. I'm going to switch back to 64-bit because to use lambda, I need to be in 64-bit, which is why I was planning on running both things in 64-bit. For some reason, the breakpoint wasn't working. So, but the big change here is look at the code. It's very different now. I'm calling get files. I have this little helper routine called make anon method. It's a little bit of magic in here, and bear with me, I'll explain how it works. And then I have an actual lambda right here. This is the lambda. In the lambda, the first thing is the square brackets. You tell it what you want to capture. So I want to capture ext, which is this. And then the lambda will take a string path and a struct, and it returns bool. So I'm using the new C++11 arrow and then the return type. And then I have my little function, and then I can refer to ext, which is here. So let's set a breakpoint here and run this. So it's going to rebuild it. And here I am. I am in my lambda, being called from Delphi. Get files, do files, walk through here, and then method reference, and then main operator, open paren, close paren. Now, main $$$0 is just the way that Clang mangles lambdas. So it uses the name of the function where the lambda was created, and then it just goes $$0, $$1, $2, $3, and so forth. So, and the operator, open paren, close paren, that's how lambdas are implemented in C++. Like I said earlier, Delphi has a class with an invoke method, whereas C++ lambdas are functors, meaning they have operator, open paren, close paren. They have a function operator, the function call operator. So that's where I ended up here. I'm in the function call operator. Now, the magic of what's beautiful here is Delphi thought it was calling an interface. It was, but the interface magically wrapped a lambda around it. Now, the reason why I need this little glue code, the make anon meth, is simply because I didn't want to cheat and show you something that you do not have. That code needs to go in the Delphi interface header. It needs to go in systeobj.h. But since we haven't shipped the version that has that, so I'm showing you a version that basically is something that you can do today. So what I did is I put the code in something called method ref here. So I'm going to bring up method ref so you can see. It's not a lot of glue. A little complicated, but we're using variadic template, forwarding, and so make anon will create a Delphi interface. But a Delphi interface is just an interface. You need a class that implements that interface. What class are we going to use? We're actually going to use a class here from method reference impl. It will implement the invoke method, but it does it using variadic templates. So when you tell Clang, I want a lambda that takes a string and a search rect and it returns a bool, this little magic basically creates an interface with an invoke method with exactly the same signature, something that returns a bool and takes a string and a search rect. And then it grabs the lambda that you passed in, stores it away here, and calls it from that invoke method. So if this is not very clear, that's okay. I mean, none of you will have to deal with this because in a future version, we're just going to take that code, drop it inside of the header, at which point you won't need this little glue even. You won't need this line here. I actually have a version of that. I just didn't bring it here. I'm using a version of the header which matches the one that ships. And this glue goes away, and you can just slap the little lambda right in the middle of the parameter where the parameter is expected, and then it would remove that extra paren also here. So this will go away, and this goes away. So it'll be very, very, very similar to the Delphi version. So I'm going to switch back to the slides and show that. So here's the version that we just ran with the Lambda interface, just showing. And oops, I did not. I thought I had put it. I wanted to put a slide where I actually highlight the similarity. Oh, I guess I can do that here. Here's a Delphi version. You can see get files, passing a function inside here. And then here's the C++ version. Besides the make anon meth, the rest is just, a lambda. And so as a final example, this is something that I did yesterday. I'm going to take one of the examples that David had on his talk for the threading, and I'm going to show a wicked case of lambda. I'm going to do a lambda within a lambda, and I'm going to do captures. So this is from David's talk. We're going to run a task in the background, and the task takes a procedure that it wants to run. So I'm going to run a lambda in that procedure. That procedure is going to sleep and then increment a value. But then when it's done incrementing the value, it's going to synchronize back to the main thread. And to synchronize back, I'm going to create another lambda for the synchronization. And here I'm going to print the date and time and say that I'm working away. So, and the key part here is when you want to capture variables that are part of a class, you actually capture this. You see here I'm capturing this. So this means the first lambda will have access to the variables of tform42. The second lambda captures this, but also captures I. I is a local variable, a loop counter in the first lambda. The second lambda is going to capture it because I'm going to use I to determine whether I'm done or not, because I is the number of iterations. So anyway, the whole thing probably will be a little easier to understand once I run it. So here, this will start the task with the two lambdas in it. This will just print the value of the value variable. So I'm just going to show it. Value is 0 here, okay? And I'm going to start the background task. Remember, the code is basically working away. So each time I print, value has incremented, if you see. Like, I'm working and it's working. I'm working and it's done. So now to kind of show you what's happening, so let's put a breakpoint here in the first lambda and call it. I'm going to And so now it started. I've clicked, and here's the breakpoint. So now you see where I am. And I'm going to show something very interesting here. I'm in a Lambda. I'm going to watch this. I want to see what the this of a Lambda has. Yeah, it's a class. And what does it have? Oh, this has another member called this. Guess what happened? The class that the Lambda created captured the this of the outer and named it this. I mean, it's not really named this, but it's not code, so it doesn't matter. There's no parser, there's no Alexa that's going to get confused there. But I should have shown that in the other example also, because you would have seen when I stopped in the Lambda that it captured the variable ext, which was the extension. So anyway, so this is just Lambdas and Delphi anonymous methods. There are a lot of features of the C++11 standard that make consuming Delphi code actually very easier. I wouldn't say very easy, but easier. Lambdas is one of them. There are other things. For range base looped, uniform initializations. We want to introduce those things to dynamic array and other classes. We want to add begin and end so that you can do, the iteration and so forth. So it would be too much to talk about. I don't have the time to talk about all these features, but there are lots of features of C++11 that just makes it a little easier to work with Delphi. So here's the parallel library in slide, just to show the example. And that's pretty much all I have. If there are any questions, I'll take some questions.
I got to turn on my microphone. Just your okay right here.
Okay.
Put this one on.
Okay.
The other one. Okay, let me take a look. I think I'm here. Yep. Okay. Let me go back to the GoToWebinar software. Okay, I got to make this bigger so I can see the. Okay. Gregor is saying Class Explorer always gives me an error. Assertion failed. Name ampersand ampersand. We expect a valid name here. File. I don't know. This is an XE6 and 7, so.
I would like to see that. I mean, the Class Explorer is based on the BCC compiler, so not on the Clang-based compiler in Win64. So ampersand ampersand, I'm assuming you have R-value reference, so maybe there's a problem where the compiler just did not understand the R-value reference correctly. I have my email on the slide, so please contact me or file a Jira or QC or something like that. I would like to look at that. I don't have an answer for.
Yeah, he's mentioning a header file, comp infocache.h. Anyway, at line 608, but Bruno's email, excuse me, Bruno's email address is there on the screen. So
yeah, please let me know. It's difficult for me to, unless I had a test case or had a little bit more information. Yep. But it's something I want to look at definitely.
And Carl's just saying, great job, very interesting. For me, Bruno, I know we were spending time. Every time I run into a Delphi-ism that I'm trying to build a C++ example, I try to figure it out first. I go into Code Insight and I type, and then I hit either dot, arrow, or double colon.
Yes.
And see one of them goes up, because otherwise I'm always having to go back into the declaration in a header in HPP and go back to the Delphi code to go, now what is this again that's in Delphi? Because again, when I'm looking side by side with Delphi code, so Code Insight in with 32-bit compiler, for example, helps.
Yes, yeah, definitely.
Right? Is that a good practice?
Yeah, it is, and I do it quite a bit too. I mean, I don't work with the Delphi runtime extensively. I mean, I'm primarily a compiler person, so but I want to use a particular feature, and sometimes I forget what method they told me, and I use Code Insight extensively. And yeah, I definitely recommend that. Open the window very big and look at everything there. And Class Explorer, I think we should have more tooling to allow us to explore code. I'm very frustrated with the fact that, I mean, I don't want to sound too bitter about it, but other languages have very, very good IDEs. C++ is not quite at the level of what other IDEs provide. And so that's something I hope will change in the next few years. But yeah, Code Insight is definitely one of those tools.
And another thing for me, besides these patterns that I now look for and go, oh yeah, okay, I have a practice in my Delphi side code for functions and procedures where I put the parentheses when there's no, even though there's no parameters, and it'll remind me in the IDE, no parameters expected.
Yes.
But at least that way, if someone sees and tries to reuse some code in a C++ app, they won't see, like what you said, a.b.c.
Yeah, it's very, very confusing. And even I don't, when I look at a.b.c, I basically have to navigate to each one of them to understand.
So. And it just saves time for somebody else down the line to go.
Yeah.
Now, in your sample code, we want to give this to people, this example with that header file for doing this little fun help that they can then remove very quickly, right? Are you going to make that somehow, or you can give it to me and I can?
It's all available. I'll give it to you right now.
Okay.
I must say that I put those examples together at the very last minute, but yeah, I'll make them available. The method ref header, you guys can use that. There's nothing that we're going to do that's going to break that, by the way. So we probably, I'll make sure we don't use the same type names in case somebody's using that. But that requirement will go away also once we move the logic inside of Delphi interface where it should live. So
yeah, because I want to take my examples that I did yesterday morning and I'll show the way we did it with the helper class with an invoke and go then and use lambdas.
Yes,
and again, a reminder to everybody, as Bruno was showing, our 32-bit compiler is still our old school non-C++ 11 compiler, but JT showed and talked about in his keynote and his C++ language future a little early technology example of how you could do things for Win32. But for the mobile compilers and for 64-bit Windows, lambdas, they're Clang and C11. Yes. So
you can use them there, and as we move more towards that, and that's when we're adding the C++ 11 features. You can say that in a way we haven't added a lot of C++ 11 features to the Delphi glue, the library that because the compilers were not quite there, but now they're getting there. So
yeah. Now I'm not sure. I'll bring this up. We could decide to edit it out of the replay of the Q&A or not. But going back to futures, not the futures in Boost libraries or in C++ 11 standard and things that are being added for concurrency in the future, but in the parallel programming library, we have a thing right now where I couldn't show using a future. Can you explain that a little bit again?
Yeah, I am going to explain that, but I'm also going to do something too because I just remembered it as we're talking there. So a Delphi generic is not available to C++ to instantiate. That's the key. So if something is a generic in Delphi, which means it has a dependent type, like T usually. I mean, it doesn't have to be named T, but let's say TList of T. You can't just go around and in C++ and say, oh, I'm going to create a TList of my customer record. Because the way templates work and generics is at the time that the compiler sees that, it instantiates the actual generic. Now, the reason I reopened an old code here is because I want to show you that earlier I did violate the very thing that I just talked about. Earlier in my example, I did create a TList _1 of int, which is a Delphi generic in my little random. Now, so why am I violating and why did it work? So the rule is you cannot instantiate something in C++, but if it was already instantiated on the Delphi side, you can use it. So if there is a future that matches exactly your description of the future in the Delphi runtime library, then you could consume it in C++. I mean, it's kind of funny. Usually that wouldn't be the case because your version of future probably will have its own parameters, its own return type, and so forth. So here, if I replace tlist of int with tlist of string, I'll get an unresolved external. I mean, I could do that so you guys can see. So if I now build this, I'll get errors. And you can see it says unresolved external collections tlist of string. That's because it happens that there's a list of int in the RTL. The RTL is already using list of int, so I get away with that. So now, but list of string is not in the RTL, so I can't get away with it. The only way I can use list of string is there's some Delphi code that explicitly instantiates that. So the future class in the parallel library is a generic. It's instantiated off a T, a dependent type. If there were a lot of pre-instantiated types, specializations as we call them, in the Delphi runtime, then C++ could consume those. But usually no. I mean, there won't be any specializations for the type that you need. So what's the solution? The solution is the generic that actually the parallel library exposes works on top of a core library that's not templated. That's actually just raw. We need to do the same thing that the Delphi generic did. We need to write a C++ template on top of that raw library. If you want to see examples of where we've done that, is tvalue. Tvalue was probably the first generic that was very used a lot, pervasively, used in the Delphi runtime. And of course, as soon as the FMX runtime started using tvalue, a lot of people come to see me and say, oh, I can't use tvalue from C++. I can't use tvalue from C++. At some point I looked at it and I'm like, oh yes, it's a generic. It's based off T. You cannot. But there's a lot of value in tvalue. I mean, it's very powerful. So what we did, we wrote a templated version of tvalue. I can show that. It's in a particular header. Let's see, where will I find this header? If I just, a quick way to navigate to it would be to open this one and then open, where's tvalue if I can remember? Of course, now I'm going to forget where we put it. It's in one of the headers. I'll think about it as I go there. It's basically, we have a template version of tvalue, and it's why am I in VCL? I should be in RTL and system.rtti, I believe. RTTI, yeah. Boom. And if we go to the no. I see that. It includes system.rtti.h. So now we'll include this guy. Find that cursor. Didn't find it. System.rtti.h. Here we go. So here's the tvalue template. So that's what we have to do. We have to do something similar to that to make the future class usable in C++. We need to basically create a template version of it that runs on top of the same low-level infrastructure that the parallel library is using, but that basically is a generic version of it. So that's the reason you can use tvalue today with a T is, if you look at this, like for example, if you call tvalue get with a T, it basically goes ahead and says, it gets the, no, not the get. The get is not one. When we want to construct, get is easy because we've already created one. Here, from, we want to construct the t-value from something. And it goes ahead and it has a little bit of meta programming. Is base of is one of the type traits. Says, we want to know whether what you've passed is base of t object or not. And depending on whether it's base of t object, we want to do the right thing. And then it calls ahead and calls t-value data helper get, which then does the, a little bit of, it's kind of the same thing that goes on in method reference where we're doing the lambda. It's a little bit of C++ magic, but the end result is you get t-value in C++.
So Bruno, it's been a long day for everybody and a long day for you, but it's a great session. I know I'll get the replay up somewhere very fast because it's very dense and for people to go through it. there's some other of these patterns occasionally I know that we've been finding here and there, but I know that you've always said to me when we find them that we'll try to do things under the covers to make it as simple as possible for C++ developers, right?
Yeah. I mean, that's my goal. Yes.
And we have a document where when we find these things, where we put them in a Confluence document internally, so that it's and a Jira entry, so that we can make sure to do as we can things under the covers, given that the world of the frameworks and some of the RTL. But of course, if you have C++, you're doing console apps and you have the standard libraries and so on. It's all good. And tomorrow, I should mention, I know Bruno's got some other things, but we're going to have the compiler team
those are my
at 10 o'clock and to talk more about some of the things going on with the compiler and libraries people are interested in, Boost and STL and so on. And also we have Eli coming in at 7 in the morning to talk about exceptions, because it's amazing. You talked about just the Delphi exceptions, for example, and Windows exceptions, but when you go to all these different platforms, the number of exception handling mechanisms that we have to do for C++, and for that matter for Delphi as well on all these platforms.
They're all unique. I mean, set jump long jump on iOS and pdata on Win64. It's the magic and the runtime and the compiler magic that goes on behind the scene is different. You can't really share that code.
So language exceptions, platform exceptions, and then different platforms, and the implementations. When I first saw the list and it was growing, I said, wow, that's really cool. That's a lot of exception mechanisms going on. So Bruno, again, thank you not only for this session, but thank you for keeping me sane some of the times when I walk over and I go, I can mostly do this, but what is this one?
I learned a lot from those sessions too.
So everybody, I've recorded this one and I've captured it, and again, we'll get the source code from Bruno, and we'll get it up for all of you to have so that you can go through this and the session as well. And again, thank